Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. This video will demonstrate how to certify a multimode fiber optic link using a FiberL 4-volt optical power meter and a WaveSource series multimode light source. There are 5 main steps in the process of certifying any fiber optic link. These steps are gathering link information and accessories, checking equipment and accessories for proper operation, entering link information into the certification tester if available, and setting an optical reference, also called zeroing, taking insertion loss measurements and storing test results, and then downloading stored test results to a PC and printing a certification test report. Before beginning any fiber test, the user must gather the necessary link information and accessories required to complete the test. Link information is used to help determine how much loss is acceptable for the fiber under test, otherwise known as a link budget. Optical loss measurements are compared to the link budget to determine if the fiber is good or not, which is the same as saying pass or fail. There are 5 key parameters that apply to any fiber optic test. First is the fiber type, which will be either single mode or multimode. In the case of multimode, this could be either 62.5 or 50 micron. Next is fiber length. It is important to know how much fiber is in the link under test in order to determine how much loss is acceptable for that particular length of fiber. Some OWL testers can be used to measure the end-to-end length of the fiber automatically, including the FiberL 4-volt optical power meter. Otherwise, the user can use jacket markings, installation documents, or other length measurement methods such as OTDR. For best results, avoid estimating the fiber length whenever possible. Third is number of connections. A connection is the point where 2 fiber connectors mate together, such as in a patch panel, wall plate, or mating sleeve. Fourth is the number of splices, which can be either fusion or mechanical. For the purpose of calculating a link budget, most cabling standards do not distinguish between fusion and mechanical splices. Lastly, the user must determine what wavelengths they will test at. For multimode, this is 850 and/or 1300 nanometers, and for single mode, this is 1310 and/or 1550 nanometers. When using a micro-OWL or fiber-OWL optical power meter, these parameters can be entered directly into the device to calculate the link budget. However, if the link budget needs to be calculated manually, this is done simply by adding together the fiber loss, connection loss, and splice loss. Fiber loss is given in dB per kilometer and varies based on the fiber type and wavelength. To calculate fiber loss, multiply the fiber length in kilometers by the fiber loss. Connection loss is the number of connections multiplied by the dB loss per connection. Splice loss is the number of splices multiplied by the dB loss per splice. Most users will follow the fiber, connection, and splice loss specified in cabling standards, such as the TIA 568. It is also helpful to determine the connector type used in the link under test, which will help determine the right reference cable configuration to use. For accessories, it is highly recommended to keep at least 3 patch cables on hand, since there are 3 reference methods: 1 jumper, 2 jumper, and 3 jumper. Mating sleeves may also be required for some link configurations. Refer to OWL's video on reference methods for more information. Finally, if testing multimode fiber, the launch cable attached to the light source will also need to be wrapped around a mandrel according to cabling standard specifications. Refer to OWL's video on mandrels for more information. As you can see, we've gathered our equipment and accessories here that we will be using for this particular procedure. As you can see, we're using the FiberL 4-volt optical power meter and our WaveSource series light source. Now in this case, there are 2 ports here. There's a multimode port and a single mode port. Some models of the WaveSource will only have a multimode port, or this single mode port could be a visual fault locator port. So what you have to do is make sure that you look on the back of the unit to make sure that you have the right model number. Now, as you can see in the multimode port here, there's 2 wavelengths, 850 and 1300 nanometers. You'll see that there are red circles here. Those circles correspond to the color of the indicator LED when that particular wavelength is active. Okay, now as you can see, we also have 3 patch cables. Now why will we need 3 patch cables if we only have 2 ends to our fiber link? Well, first thing we will need, because it's a multimode test, we need a mandrel wrapped cable, which I have done here. The second patch cable will be used with the fiberall on its side of the test. However, one of the key features of the fiberall is that it can be used for length measurement. As you can see, there are 2 ports here. There's a detector port and a light source port. These 2 ports are used for the length measurement. There are two patch cables connected into the top here that go connect into the link, and then a third patch cable, like this one, is used at the far end of the cable to produce a loop. That loop is used to calculate the distance from the one end to the other. Now, the first thing we need to do is make sure that we check our equipment for proper operation first. And that involves connecting our patch cables to our testers just to make sure that they are reading correctly. So, first thing we do is we power on the equipment. The fiberall is the bottom middle key here. And on the WaveSource, it's this lower left-hand key. Now, as you can see, the indicator LED is lit red, so it's outputting 850 nanometers right now. Now, and with the fiberall, we see we come up to an operating mode screen. Okay, our operating mode screen shows several options: simple meter, certification meter, and technical support. For the purpose of checking our equipment, it's just easier to use simple meter mode. So we'll press F2 to select. Now, as you can see, we have a reading on the screen here. It's not a power reading, it's showing under. This is because the dust cap is still on the detector port, if you can see that there. The reason it says under is because there's no light coming in. But what we need to do next is test our patch cables. So we'll test each one of the 3 here. We need to take off the patch cable here, or I'm sorry, the dust cap off of the fiberall, and also the dust cap off of the multimode port on the WaveSource, and then we will connect in. Okay, one key thing to remember here is that you're set to both the same wavelength on both units. So 850 nanometers here, and then 850 nanometers here. If they were not reading at the same wavelength, you would have to switch them. To do that, there's a wavelength button here on the WaveSource, and then there's a wavelength option, which is F3 here on the fiberall. Now, as you can see, we have a reading of minus 19.67 dBm. If you look here, there's dBm units. This is a way of measuring the absolute power coming out of the light source. Typically, we calibrate our light sources at minus 20 dBm according to standards. Now, as you can see, we're a little bit above that. The reason we're reading a little higher than minus 20 is because minus 20 is based on a mandrel wrapped reference level. As you can see here, there's a mandrel wrap. But what we're trying to do is make sure that our patch cables do not have too much loss in them, such as the value we're looking for is minus 21 dBm or lower. You know, if we exceed minus 21 dBm, it's probably time to replace the patch cable. So once we verify that this patch cable is good, we simply remove it from the testers and we set it aside. It's always a good practice to put the dust caps back onto the patch cables when we're done. Okay, and what we'll do is we will do the same for both of the other patch cables here. So again, plug in the detector port. Let's see here. Okay, there's one. Then we plug into the light source port. And again, we see we're reading around minus 19.85. We're still within our spec of minus 21. So this patch cable is also good. So again, we put the dust caps back on and set this patch cable aside. And finally, we attach our mandrel wrapped cable. Okay, this is the cable we will be using for setting a reference, actually zeroing out our equipment. This is the important one here. So we plug this in, and now we should be reading closer to minus 20. As you can see, minus 20.15. This is perfectly acceptable. We haven't exceeded minus 21, so what we can be assured of now is that we've checked our equipment, we've checked our accessories, they all seem to be in good working order. So now we are ready to set the meter and source up for setting a reference and then taking measurements. Once we've checked our equipment and patch cables over for proper operation, it's time to enter the link information based on the link that we're testing. And we can do that when we're in certification meter. Now, if you remember, we're in simple meter right now, so we just simply hit the done key to return back to the operating mode screen. Now, you can see simple meters highlighted, so we press F1 to advance the selection in the list, and then press F2 to enter certification meter. Okay, now we see the start menu. And we see the option number 1 is the link wizard. The link wizard is the what we call the setup process for entering your link information. So we're going to press number 1 to enter the link wizard. Now the next screen we see is select link. Now as far as the fiber is concerned, a link is simply a group of fibers that have identical characteristics. So the same fiber type, the same fiber length, same number of connections, and same number of splices. As long as you have any number of fibers that meet those characteristics, you can use this same selected link position here. What we're going to do is we're going to select option number 1 here, and we're going to press F2. Now, we can name the link whatever we want to based on the job that we're doing. For this demonstration, I'm just going to leave it at the default value. When you're done entering the name, you simply hit done. The next screen is asking us to put in the date of test. If you can see that here, the format of the date is 2-digit month, 2-digit day, and 2-digit year. What we're going to do is we're going to enter this data in. Now this is important because this is the day that you're actually doing the test. So if you're testing tomorrow, you can put tomorrow's date in. But for now, we're just going to put in today's date. So that's 03, and then we need to put in a special character in between our digits here. So special characters are on the 0 key. So I'm going to hold the 0 key until I get a dash there. And I'm going to put the date in, 25, and then another dash, and then the year. Okay. When I'm done entering the date, I simply press done to continue. Now, the next screen is the fiber standard screen. Most of the time you'll pick the TIA-568. That's the standard that's used most often in the United States. However, there are some European standards such as the ISO standard you see here. There are some Ethernet standards, so 1 gig, 10 gig Ethernet, as well as user-definable standards for advanced users. User-definable standards allow these advanced users to configure their own TIA type link budget. But for now, what we're going to do is we're just going to take the default value here, and in order to select, we press F2, and then we're at the fiber type screen. Now, as you can see, there are 4 fiber types here. These are the fiber types supported by the TIA standard. 2 of them are multimode, so you have to look at what type of fiber that you're testing that day. In this case, we'll pretend we're testing 62.5 micron multimode fiber. So we'll press F2 to select. And now we come up to where we have to enter the length in. Okay, there's 2 different methods. Either you can enter the length manually, which is simply typing the length in by hand, which is much easier than actually having the tester do it, or you can have the meter do it. What I'll do is I'll demonstrate both methods here. First, I'll use the meter to measure the length. So we'll press the number 1 to start the length measurement process. Okay, as you can see on the screen here is a little description about how to connect your tester in to take the length measurement. Now, for this purpose, we will not need the WaveSource. This is not used for length measurement. So we can disconnect our patch cable from the WaveSource and then set it aside. We won't need it until later. Okay, but what we will need is the fiber owl. So what I have done here is I've got a simulated fiber link. Now this obviously is not a fiber link. But what this is designed to do is to show that there's a patch panel on one side and then a patch panel on another side. So in two different closets, for example. Okay, so what we're going to do is we're going to connect in the way that the fiber owl specifies here. So you connect fiber A and fiber B, fiber pair required. So what that means is you need two fibers in your link in order to take this measurement. What we're going to do is we're just going to pretend we're going to use number 1 and number 2. Okay, it doesn't matter which port you plug these into because we're simply making a loop. Okay, now this is where this right-hand port, this SC port here, comes in handy. This is the only time we're going to be using this right-hand port is for length measurement. But what we're going to do is we're going to connect in to ports 1 and 2 on the near end, and then at the far end it says patch fiber A to fiber B at the far end of the link. So what we do is we locate ports 1 and 2 on the far end, and we take our third patch cable, like this one, and we plug in to the far end of the link. Now, as you can see, we've made a loop. We're going from the transmit port through the link and come back into the receive port. Once we've made this connection, press F1 for done. As you can see here, we have a fiber length of 6. Now, there's not a lot of fiber in here, so this is a very short link. But your link might be longer than that. It might be 100 meters, for example. Whatever the length is going to show up here. Okay, and it's going to be within 6 meters of that value. So once you have the length entered there, you simply press done, and a review screen shows up telling you what the length is that you're going to be entering into the setup process. Now we're going to use a more realistic value. I'm going to put in 100 meters. Let's pretend 100 meters. But let's say that you wanted to enter the length manually. This is the screen you would have went to if you did pick the manual length entry option. As you can see, you would like to, in some cases you want to enter the length in feet. So let's say 325 feet. You can do that with this fiber owl by pressing F2. You're toggling the measurement units here. So there's feet, meters. So you can see, you get the idea there. So what we're going to do is we're going to enter in feet, and we're going to backspace and enter the number 325. 2, 5. Okay, so now we have 325 feet. This is the length of fiber that we're using for our setup. Once we've entered this number in, we hit done. Now, once we've done entering the length, we don't need these cables anymore. So we can disconnect these cables from the link. This third patch cable we can set aside. We will not be using this cable anymore for this procedure. So we just set it aside. Replace the dust caps on the ends here. And then we will disconnect from the near end with our 2 test cables. Okay, we'll put our link aside for now. And we'll take patch cable out of the light source port, because now we will not be using the light source port anymore for our procedure. We've used it for length measurement, and that's all it's used for. Okay, so we replace the dust caps, and we set that patch cable aside. Okay, now the next question it's asking is inline connections. Now, an inline connection is simply a patch panel or a wall plate or a mating sleeve, something like that, where 2 connector tips are meeting together. Now, if you can picture, inside this link, the back side of the link will have patch cables coming into the back of this mating sleeve here. And when you're connecting in to do your test, you're connecting to the front end. The connection made between these 2 connectors is called a connection. That connection is what you're trying to measure here. So because we have 6 fibers with the same characteristics, both sides have, all the fibers on both sides have 2 connections. So what we're going to do is we're going to enter in the number 2 here for 2 connections, and then we hit done. Now, the last thing we'll enter is the number of splices. Splices are different than connections, but they are still part of the connection process. Most of the time, multimode links will not have any splices in it, unless you happen to be using no polish, no epoxy connectors, such as unicams, OptiJacks, that sort of thing, where the ferrule of the connector itself has a little mechanical splice inside the ferrule. So you would not be incorrect to enter 2 here if you were using no polish, no epoxy connectors. So let's assume that we did use unicam connectors, and we will press the number 2 to say that both sides of every fiber have a unicam splice in it. We'll press and enter the number 2 and hit done. Now, finally, we have a review of the link information that we're entering. We simply compare this to the link information we've gathered earlier and make sure that it's correct. If it's not, we simply press F3 and go back and re-enter it again. But for now, we're using the 568 standard, 100 meters of fiber, so 325 feet actually equals 100 meters. 2 connections, 2 splices, and we're testing 62.5 micron multimode fiber. So we're asked if this is correct. We say yes and press F1. Now, the second main step here of setting our equipment up is to set a reference. Setting a reference means zeroing. This is where we'll need the light source again. So we'll bring that back into the picture here. We won't need this cable right here, but we will need our mandrel wrapped cable. This is our reference cable. Now, what we're going to do first is we're going to set the wavelength reference for 850 nanometers. Since we have 850 nanometers highlighted here, we need to make sure that on our power meter that we are set to 850 nanometers as well. Now, we could set a 1300 reference here with the 850 light source powered on, but the reference would not be correct. This is why it's important to make sure that the wavelengths are always matching. So to switch the wavelength, we press F1, and you'll see the asterisk moves in front of the 850 nanometers. Once we've verified that the testers are on the same wavelength, we simply press F2 to begin the set reference procedure. Okay, now we can see on the screen it says connect 850 nanometer source. We've done that. We've verified that it's the right wavelength, and we also have to verify that the source must be in CW mode. The LED must not be blinking. What I'm going to do is I'm going to demonstrate what that means here. If you can see here, there's a button that says CW and mod. CW means continuous wave. When you're taking measurements for insertion loss, you need to be in continuous wave mode. Likewise, you need to be in continuous wave mode when you're setting a reference. Now, if the light source is modulating, you'll see that the light is blinking. You can't properly set a reference off of a blinking light source. So you have to make sure that you're not blinking. If it is blinking like this, simply press that CW button and it goes solid. So once we make sure that our LED is solid, it's always on, it's in continuous wave, we press F1 for done. And then we confirm that we want to set the 850 nanometer reference. Just a way to double check again. We press F1, we save our reference, and as you can see, we have a reference of minus 20.82. We're getting a little close to our minus 21 failure value, but this is actually okay to be close, because what we're doing is we're zeroing out any imperfections in the cable. Once we have set our 850 nanometer reference, we can do one of 2 things. We can either press done and say that we only want to set an 850 nanometer reference, in which case we're only testing at 850. For our purpose today, I'm going to demonstrate how to test with 2 wavelengths. So what we need to do is we need to switch the wavelength over to 1300, and then again press the set procedure. Okay, now follow the screen. It says connect 1300 nanometer source. Okay, as you can see, our indicator LED is red here. I don't know if you can see that, but it's red. In order to switch it to 1300, we simply press the wavelength button. As you can see, it flashes briefly and then goes back to solid. You can see that it's a green LED now, which means it's outputting 1300 nanometers. We've made our connection. We press F1 and then F1 to confirm. And as you can see, we have a reference level is minus 20.18. This is fine. So what we've done here is we've zeroed out our equipment at both wavelengths that we're using for the test. Once we've done that, we can simply press F3 for done. And we're given a screen that says begin taking readings for fiber link number 1. What we're going to do here is we're going to press F1 for yes. We're going to say we're ready to take readings, and we're going to double check that to make sure that our equipment is indeed zeroed. And what I'm also going to do is demonstrate a feature that's nice about the WaveSource. It's called auto mode, which lets you test 2 wavelengths at once. Now, the first thing we need to do is check our reference level. When we're zeroed and we're attached with our reference cable, our reading should be 0. Now, as you can see, it says +5. This is not right. But if we look at our equipment, we can see that our power meter is set at 850 nanometers. Okay, so what that means is that we need to press F3, switch to 1300, and we have a value that's roughly 0.0. Now, if we want to check the 850, we simply change the wavelength on both sides. All right, as you can see, it's minus 0.03, but it's still very close to 0. So what we've done is we've verified that we've zeroed out our equipment. Now what I'd like to do is demonstrate auto mode. Okay, auto mode is a way of testing 2 wavelengths, 850 and 1300 in this case, at the same time. This is a tremendous time saver. So this is simply done. On the fiber outlets, there's an auto button. You simply press that. You'll notice that your wavelength number is switching between auto and 850, auto 850. What this means is that the fiber owl is scanning incoming light for an auto testing signal. Now, the auto testing signal is that flashing signal we saw before when we switched our wavelength. It flashes on and off at a specific frequency that tells the fiber owl to switch to a specific wavelength. Now, the next thing we need to do is set the WaveSource into auto mode. Okay, there's also an auto button here. Now, usually this takes a little bit of practice. It's a little touchy because you have to press and hold the auto button until you see this indicator LED start flashing, and then you immediately remove your finger. So what I'm going to do is I'm going to demonstrate that here. And as you can see, after a few seconds, you'll see that the light source begins switching colors and it's flashing back and forth. So flashing green, solid green. Flashing red, solid red. And as you can see on the screen, we see 2 wavelengths. Okay, we have our 850 nanometer reading up here, and we have our 1300 reading down here. As you can see, they say pass. They're both roughly 0.0. What we've done is we've demonstrated that not only are we zeroed out, but we're actually taking dual wavelength measurements at this point. So once we've set our equipment into auto mode, what we can do is we can leave it in auto mode for now, and then take the units to opposite ends of the link. Now, the WaveSource will stay attached to this reference cable here, the mandrel wrap cable. This has to be attached to the launch point, but what we'll do is we'll take that to one side. And then, as you can see with the fiber owl, we have a big loss reading. This is normal. We're measuring room light right now. We're not measuring the output of our light source. So what we do is we take the fiber owl with its patch cable to the other end of the link. Now, for our purpose here, I'm going to again use the simulated fiber link that we see here. Remember that we have 2 closets. We have closet A and closet B. What we're going to do is we're going to take dual wavelength measurements. Okay, so first of all, let's cover a little bit about what is shown on the fiber owl screen here. And in order to do that, I'm going to connect into fiber number 1 first on both sides, so that way we can acquire an auto testing signal. So again, we use the detector port here, and then we plug into port number 1 in our patch panel on this side here. Now, after a few seconds, you'll see that both wavelengths will appear on the screen. Okay, as you can see, we have 2 loss readings here. With 850, we have 2.05 dB of loss, and then at 1300, we have a loss reading. Sorry about this. We have a loss reading of 1.87. In this case, 1.92, roughly, 2 dB of loss each. Now, as you can see, we're passing because we haven't exceeded our link budget. So this is good. We want to see a pass reading. Now, as you can see, it says pass and the wavelength numbers here, and the big numbers here are their loss values in dB. Now, if you look here, we see our fiber link number 1. This is our link name, or the name of our job, for example. We'll see new name here. The reason this shows up is because we have not stored any data yet. This will change when we store our first data point. Now, again, on the right-hand side, we see dB. This is our loss reading. HZ means hertz. It's indicating that there is an auto testing signal going on. This next number down is the temperature. The percentage here is battery life, and then we show our wavelength here. And as you can see, it's switching between 850 and 1300. It corresponds with the currently output wavelength on the WaveSource. And then again, you have your 3 menu options at the bottom of the screen here, corresponding with these 3 F keys here. Now, what we've done here is we said, okay, we have a good reading. What we want to do is we want to save this reading and go on to the next fiber. So now that we have both readings on the screen here, we can simply press F2 for store. Now, the first time we store a reading, it says enter fiber name, and the meter will append a number to identify individual strands. So what this means is you're putting in a little prefix here that better describes the patch panel that you're in, and then the fiber owl will append the number 1 because you're plugged into port number 1 here. They'll do that automatically, and it'll auto increment by the number 1 each time. So what we're going to do is I'm just going to leave it here for demonstration purposes, and you'll leave it at the default value. You can change it to whatever you want, but if you do change it, it's always recommended to make sure that you have a separator, such as a colon or a dash or a dot or something, between the prefix and the appending number that the fiber owl puts on. This makes sure that the numbering stays in sequence. So once we're satisfied with our name here, we simply press done. And as you can see, we have our loss readings, our pass values, wavelengths, and all our link information. As you can see, it says fiber number 1. We're plugged into port number 1 here, so fiber number 1 passing. Okay. Now on this screen, if we are happy with our result, we press F3 for save. If we want to rename the link name, we press F2. If we want to abort the reading, let's say it says a failure, we want to abort and try to fix the fiber before we try to store it again. So what we do is we're satisfied with this result. We press F3 to save. Okay. Now, as you can see, it'll take a little bit of time to reacquire an auto testing signal. But remember, we're still plugged into port number 1. So what we got to do here is we need to plug into port number 2 now. Okay, and you will see what happens here when I do that. Okay, we'll take the patch cables and plug them into port number 2, and it's very important that both technicians on either side of the link are in constant contact here to make sure that you're on the same wavelength and the same port. Now, the nice thing about the WaveSource is that because you're in auto mode, it's ensuring that you are on the right wavelength all the time. As you can see, it reacquired the connection here. It's producing our loss reading. We're in fiber number 2, so we're going to press F2 to store, and then save. Okay, and what I'm going to do here is I'm going to speed up the process and just store 6 readings very quickly. Okay, now one key thing to remember here to watch when I make this connection to the next fiber, you'll notice that when the fiber owl loses its sync, the store button goes away. Okay, that's a failsafe in the fiber owl to make sure that your fiber numbers stay in sequence, that the reading number 6 has both wavelengths in it. Once you plug or make your connection here, you'll notice that it takes a little while for the store button to come back. Once you have acquired both wavelengths, then the store button will reappear and you can actually store your last reading here. Okay, now we've stored 6 readings and they were all passes, so we're happy with those results. Once we're done testing all of our fibers, we can disconnect our patch cables from from the links. We don't need them anymore. The next step in the process is to take the fiber owl to a PC and download the results to produce a certification report. Once data has been stored in the optical power meter, test results can be downloaded to a PC to produce a certification test report. First, install the USB driver and OWL Reporter software from the supplied CD or a USB flash drive. Connect the power meter to the PC using the supplied USB cable. And then power on the power meter. Then start the OWL Reporter program. The program shortcut can be found in the Start menu. When the software has started, the screen will initially say no data loaded as shown here. Download the test results to the PC by pressing either the download menu option or the download button. While downloading, the status bar will say searching for OWL device. Once the test results have successfully been downloaded, the data will appear in the OWL Reporter screen. The test results can be viewed in 2 different formats. This view is called Circuit Detail View. It shows detailed information about a single fiber run. The other view is called Circuit Summary View. Circuit Summary View shows basic information about a group of related fiber runs. Certain buttons become active when Summary View is selected. Pass-Fail, Overhead, which shows how close the test is to its fail point, or Optical Loss. Toggle between Summary and Detail View by pressing this arrow button. Test results can be printed from the File menu or Printer button. The printout will show test results based on the currently selected view. The reports are formatted to look like the OWL Reporter screen. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more information about additional instructional videos, or OWL fiber optic test equipment in general, please visit OWL's website at owl-inc.com. I'm Professor Jim Powers. Thanks for watching.